C++ is in big trouble. It's being abandoned by companies and government agencies because of memory safety issues, and the creator of C++, Bjarne Stroustrup, is not happy about it at all. Here's a new article by The Register titled C++ Creator Calls for Help to Defend Programming Language from Serious Attacks. It goes on to say Bjarne Stroustrup, the creator of C++, has issued a call to the C++ community to defend the programming language, which has been shunned by cybersecurity agencies and technical experts in recent years for its memory safety shortcomings. It goes on to say that memory safety issues cause the majority of vulnerabilities in large code bases. And with high-profile, financially damaging exploitations of these flaws, industry and government security experts over the past 3 or 4 years have been discouraging the use of C and C++ while evangelizing languages with better memory safety like Rust, Go, C#, Java, Swift, Python, and JavaScript. The article goes on to say that the C and C++ communities have tried to address memory safety issues. For example, through projects like TrapC, FillC, MiniC, and Save C++. Unfortunately, progress has been slow. Now, the creator of C++ also points out that it's clear the issue is not just slow progress, but also the absence of public narrative that can compete with the tech industry's adoration of Rust. Which is kind of funny to me because, yeah, Rust gets a lot of love from enthusiasts, but it also gets a lot of hate. In fact, I can't go a day without reading a comment saying how pointless Rust is, or that it's overly complicated, or it's going to die out soon. At the end of the day, if a language has adoption, then you're going to have people that love it, and you're also going to have people that absolutely hate it. But yeah, I would agree that Rust is particularly adored in the security space. The article goes on to say that the creator of C++ has proposed a memory safety framework called Profiles. And he wrote that this is clearly not a traditional technical note proposing a new language or library feature. It is a call to urgent action, partly in response to unprecedented, serious attacks on C++. He said, I think WG21 needs to do something significant and be seen to do it. Profiles is a framework that can do just that. So Bjarne is serious that something needs to be done about memory safety in C++, and he proposes a framework called Profiles to address the issue. So what is the Profiles memory safety framework? Before I go into the details, a quick flashbang warning. The background of this presentation is completely white, so keep that in mind. All right, here's a presentation by Bjarne Stroustrup called Safety Profiles: Type and Resource Safe Programming in ISO Standard C++. We can see here that, again, the main reason for this proposal is because there is concern around memory safety. He states the overarching software community across the private sector, academia, and the US government has begun initiatives to drive the culture of software development towards utilizing memory safe languages. Say the NSA advises organizations to consider making a strategic shift from programming languages that provide little to no inherent memory protection, such as C or C++, to memory-safe languages when possible. So this is a real threat to the C++ community, and keep in mind that this presentation was delivered in 2023, so the C++ folks have been thinking about memory safety for quite some time. It goes on to propose a strategy for addressing the memory safety problem called Safety Profiles. And it goes on to say that safety profiles are a cocktail of techniques, not a single neat miracle cure. So safety profiles include a combination of static analysis tools, coding rules, and libraries that all help enforce safety. Also, I believe it's called profiles because you can opt to different profiles. For example, if you're working in aerospace, you might need stronger guarantees than if you were to work in, let's say, something like the automotive industry. Now, one part of this proposal I found very interesting is this slide on dangling pointers. It says we must eliminate dangling pointers. And to do that, we're going to use a combination of rules, one of which is distinguishing owners from non-owners with this owner annotation, which is pretty interesting because it looks similar to Rust's ownership model. It's funny to see C++ borrow from Rust because when Rust was created, it borrowed from C++, specifically the RAII pattern and smart pointers. Now, in the article, Bjarne says that he feels strongly about implementing the safety profiles proposal. And to address any skepticism that this is a real threat to C++, Bjarne points out this US government product security bad practices report from last October. Now, this report is by the Cybersecurity Infrastructure and Security Agency, and it states that the development of new product lines for use in service or critical infrastructure in memory unsafe languages like C or C++, where readily available alternative memory-safe languages could be used, is dangerous and significantly elevates risk to national security, national economic security, and national public health and safety. Now, the article goes on to say that this report states that manufacturers should have a memory safety roadmap for products using memory unsafe languages that leads to the elimination of memory safe vulnerabilities, or should adopt a memory safe programming language, which Bjarne says he considers a credible threat to C++. So it's clear that memory safety is really important to government agencies and security-focused companies. And the C++ community is feeling the pressure to improve the language. Now, C++ isn't going away anytime soon. There's a ton of software written in C++ over the years, so I really hope that they do figure this out and they're able to modernize the language. That said, one of the big disadvantages of C++ is that it could be memory safe if you opt in, whereas a language like Rust is memory safe by default unless you opt out. Also, I can't emphasize enough how critical it is that Rust has standardized tooling. We have a standardized build tool called Cargo, a built-in testing framework, and a centralized repository of third-party libraries called crates.io. I think the fact that the C++ community is taking memory safety more seriously is a net positive, and it's really interesting to see how important memory safety is becoming in the cybersecurity space. But let me know what you guys think. Will C++ be able to modernize in time? And what do you think of government agencies and security-focused companies moving more towards memory-safe languages like Rust? And if you want to learn Rust, the memory-safe language these companies and government agencies are raving about, then make sure to get your free 4-day Rust training at letsgetrusty.com/bootcamp. And then click here to watch this video next, which YouTube thinks you'll absolutely love. I'll see you in the next one.